Yeah, so this is the problem number 9 from projecteuler.net. The name of the problem is Special Pythagorean Triplet, and it reads the following here. A Pythagorean triplet is a set of three natural numbers, a smaller than b, which is smaller than c, for which a squared plus b squared is equal to c squared. This is a Pythagorean theorem. So they give an example here, 3 squared plus 4 squared is equal to 25, which is equal to 5 squared. And they claim there exists only one Pythagorean triplet for which a plus b plus c is equal to 1000. And they ask us to find the product a times b times c. I think you need to look at for code for at least finding these variables here. You're gonna have to iterate through them until we get to 1000. I guess we can start with that, and then we can see if we can improve on top of that through the through limiting the search space. Right, so let's go through the implementation then. Let's create here our problem 9 directory, and then we create our file here. Just to clarify here, we want to find like three numbers a, b, and c, in which a plus b plus c is equal to 1000, and a squared plus b is squared is equal to c is squared. I just want to then first define a function that will verify if this is a Pythagorean triplet, right? So I'll create it like this, Pythagorean triplet, and it receives three integers, a, b, c, and it will return a bool. This will then check if a, b, and c are a Pythagorean triplets. Then these are the three numbers, true or false, for the check. No, I don't want to write any comments for this a, b, and c. Now actually I'll just check return if a plus b is equal to c squared. I guess we can do something like this, right? We can test with the example they give us, which is 3, 4, and 5, right? So let's just do it. Pythagorean triplet, 3, 4, and 5. We can test if this is right. So problem 9, and it's true. If I put another number here, so for example 6, this should give us a false. I don't want to write actual unit tests for this problem, so I wouldn't test more numbers here, but I will assume this is right. Okay, so based on this, we can make our code. My idea here is to iterate through the values of a, b, and c within the range of 1 to 1000, smaller than 1000, and then we check which one of them is actually equal to 1000. If so, we check if they are Pythagorean triplet, and we save the ones that it is, and we stop the loop at that. For that, we're going to need a few loops here. So let's go for a first in the range of 1000. We do the same thing for b. We know that a is smaller. They also said that like a is smaller than b and is smaller than c, right? So we can start here with a plus 1 up to 1000. And then for c in range of b plus 1 up to 1000. Here we're going to check first if a plus b plus c is equal to 1000. Right? If it is not, then we just completely ignore it. We just don't do anything. And we also need to check if they form a Pythagorean triplet. If they do, we have everything that we need. We can print a, b, and c, and the result should be a multiplied by b multiplied by c. And once we find this result, we don't need to check anything else. They said in the problem description here that it's just exactly one of these triplets, so we can just stop there. So I'm going to start my search here, probably. Let's find out if we find the right answer here. Python, problem 9, let's run. And now we have an issue because this is quite slow. You saw that it took a while to run the result. Actually, we got the result. It says that this is the Pythagorean triplet, 200, 375 and 425 and give us this result here, which I'm assuming it is the response. Let's check if this is the answer. And it is the answer. But I'm not satisfied with it because this was quite slow to run. If you saw, it took several seconds to run. Let's find out here how long it actually took. It took several seconds. Start time. We're doing a little profiling here. Let's do this minus the start time. That ought to do it. Let's see how long it took. It took several seconds to run this algorithm, which I think it's not good enough for what we want to do. You see here, it took 8 seconds. I think we can do better than this. We are iterating through A, B, and C to find these numbers. We don't need that. If we know 2 of these numbers, we know the other, right? Because we know that they need to sum up to 1,000. So let's say that this is solution number 1, okay? I'm going to comment this solution because we're going to do a better solution. So here we're going to do solution number 2, right? So in this solution number 2, I want to do the same thing for A and B, right? So A and B is going to be exactly the same, but I am going to get C by making the subtraction of the results. So we have, for example, 1,000 minus A minus B should give us C, right? They need to sum up to 1,000. If that's the case, then I just need to check if they are a Pythagorean triplet. Yeah, so we have this result here, A and C, right? And then we just check if they are a Pythagorean triplet. If so, we stop whenever we find the result. This should give us the answer, and it should be faster than the previous one. Just remember, solution number 1 gave us 8 seconds. Let's see how much faster this will be this time. And check it out. Same result in 0.079 seconds. So just by reducing one loop, we can get it really fast. We can express this kind of like this time complexity in terms of mathematics. So as you can see here, each of these nested loops, you have to go through 1,000. And then if each of the steps in this loop, you have to go through 1,000 steps. And each of the steps of the second loop, you also have to go through 1,000 steps. In this case, our complexity, assuming n is equal to 1,000, our complexity here is, our time complexity is O(n) cube. For computers, a cubic complexity is really slow. The solution number 2 is slightly better than that, since we are getting rid of one of the 4 loops. So our time complexity, instead of like a cubic, is just a quadratic one, right? And then comes the question, can we do a linear complexity in which a solution, for example, solution number 3 here, that it will be just O of n. Let's see what we can do here. We know that A plus B plus C is equal to 1,000. And we also know that A squared plus B squared is equal to C squared. And we also know that we also isolated one of our variables, C, so is equal to 1,000 minus A minus B, right? We have this. What if we just replace this, by plugging in C into here? We have, then we're gonna have here, this is the same, but this is different. This is gonna be basically this is squared. To open this up, we're gonna have to use the factorization here. I forgot the name of it in English, how to call this, but it's gonna be something like this. Plus A squared plus B squared plus 2 times 1,000 times A plus 2 times 1,000 times B plus 2 times A times B, so 2AB, right? This in turn will be something like 2,000A, 2,000B plus 2AB, right? So based on that, we can isolate some of these variables here, and we can already cancel stuff. So for example, this A squared, B squared with this here, we can just cancel these two here, right? From both sides, which leaves us with something like this, equal to just this, right? Now we can actually isolate either A or B. Let's isolate B to one side, right? We can just put 2AB is equal to minus 2AB is going to be equal to, if we pass this to the other side, it is going to be this 2, right? Minus 1000 squared. Okay, and let's pass this one here to the other side as well. So this is going to be something like this, right? And this side keeps the same. Okay. With that in mind, we can just isolate B here and just put the rest inside, which is going to be something like this, is equal to this. And then we just pass this part dividing in the other side. B is equal to all of this divided by this. So we could then, as you can see here, represent B in terms of A. And we can represent C in terms of A and B. Therefore, with this formulation, we should be able to make a linear code, right? We can just iterate through A. From A, we find B. From B, we find C. And we check if it's a Pythagorean triplet. Let's give it a try. For A in range of 1000. And then B should be something like this, right? Okay, 1000 squared is 1,000,000, right? Is this right? No, 10 more. And this is just 2A. Okay, so we are not playing with floats, so everything here needs to be an integer. So I'm converting that to an integer. And then we can just calculate C in the same way we calculated it before, right? So C is just 1000 minus A minus B. And the rest is just the same as it is. So here we can just calculate the Pythagorean triplet and print the result as we get it. Let's also calculate the time. And let's see if this result is actually what we're expecting. Let's see. Okay, oh, it also executed this part. And we got actually an error. This is not as it's supposed to be. Why 0? Oh, because we shouldn't use 0 here. We should start from 1. Right, because from this 0 should be incorrect. Now we got the correct number. So yes, the result is right. And the time that to run this is even smaller than this. You can see here is orders of magnitude smaller. I like this problem quite a lot because we had the opportunity to start from a very naive solution, which is a cubic solution, and then we improved it a little bit. We got it to a quadratic solution, did a bit of a mathematical cleverness here, and we even improved it to a linear solution. I don't think there is a way to improve more than this, but I'm pretty satisfied with this result. I hope that you liked it as well. Feel free to comment, like, share, subscribe, sign on the notification bell if you want to hear more about these kinds of problems. Let me know what you think, and I'll see you next.